Hello everybody, this is Rudra Pradhan here. Welcome you all to BMD lecture series. Today we will continue with predictive analytics and the topic of discussion is on panel data modeling. The problem starts with understanding the data and then we will connect with a model. As a result, we will get to know more details about the panel data modeling. In the last couple of lectures, we have solved so many problems by using predictive analytics. In so many tools are there, and every time we are solving problems with respect to data, and that too in a time series format or in a kind of cross sectional format. But in this particular lectures, we will go little bit more about this. Sometimes by using cross sectional data or time series data, so the sample size may not be strong enough. So, as a result, so we like to pool both time and cross sectional data, so that we can have more sample size and then we can predict the kind of problem in a much better way. And in the same times, using panel data models, we can solve some of the additional business issues which we cannot actually solve through either time series data or through cross sectional data. For instance, we have already discussed dummy modeling technique, and when we are actually dealing with more number of business firms with more number of time periods. So, sometimes while predicting dependent variable with the independent variables, we can check the individual impact, that is the business firm impact on the relationship between dependent variable and independent variable, and again we can also check the particular time impact. Like in the last lectures which we have already discussed about the dummy modeling. So, having the relationship between y and x, we can actually study the impact of genders, we can study the impact of different religions, we can study the impact of education and so on. So, similarly, we can also study the quarterly impact between y and x and monthly impact on y and x. So, now these are all very valid kind of structure when we when we will connect with the dummy modeling and panel data modeling. So, in fact, panel data modeling is a kind of extension to dummy modeling. So, the understanding of this particular structure requires the clear cut understanding of the regression simple regression structure and the dummy structure. So, after knowing all these details, then you can solve some of the business problem dealing with panel data structure. So, let us start with the kind of discussion. So, here the idea is to go for the predictive analytics by using both cross sectional data and time series data together. In the earlier problems, we have already dealt so many problems either through time series data only or through cross sectional data only. Even using the time series data, we can apply the dummy modeling and then we can check the structural break, we can check the before and after impact of a particular crisis or war, something like that. And again within a kind of cross sectional data, we can we can try to find out the individual impact. So, now we are just clubbing both time series and cross sectional data, and that means technically we are now in a position to study both time impact and cross sectional impact together. In the earlier case, when we have a time series data, we can only check the time series impact, for instance like monthly impact, weekly impact, quarterly impact. Now, in the cross sectional side of data, we can have a individual impact, organizational impact. So, now since we are clubbing both cross sectional data and time series data, so we have a extra we have extra advantage to study the impact of individual business firms, and at the same times we can go through individual time impact. So, how we have to deal all these cases. So, we can better we can study through penal data modeling. So, now so the first and requirement of this particular lecture is to understand the penal data structure, and then the same problem we can connect with the cross sectional modeling, then with the time series modeling, and we will go through pool data structure, and then finally penal data structure. So, that means, so we have a kind of problem that means to predict a dependent variable with respect to independent variables. It may be a bivariate structure, it may be a multivariate structure, but by the way, so we have more number of time series data, and at the same times we have more number of cross sectional data. So, that means assuming that there are 10 company and 10 different time periods. So, every company is having 10 different data points, and similarly in every time periods we have actually 10 different company data. So, then altogether there may be a sample size of 10 into 10 is something called as 100 data points. So, within the particular structures we can check what is the individual farm impact while studying the impact of independent variable on dependent variable, and again what is the time series impact while studying the impact of independent variable to dependent variables. So, that means when actually we have actually big problems, so your sample size should be also big enough, otherwise penal data handling is a kind of a difficult task or something like very complex process. So, let us see how is the kind of structure altogether. And so, what I told you earlier, so that first of all you understand the penal data structure. So, penal data can be defined as the data that are collected as a cross sectional, but then they are observed with kind of periodically, maybe annually, maybe weekly, maybe quarterly, maybe day wise, whatever may be the structures, but it has both cross sectional kind of structure and time series kind of structure. For example, the economic growth of each parts of India from 1971 to 2017, or profit of various companies listed stock market, and that too from 1991 to 2017. So, this is a classic example through which you can actually just check the kind of penal data structures, and then or something like individual impact of a particular country, or individual impact of a particular time period. And for examples, we may like to develop a model that can explain the variations of regional economic performance in India, that is there with respect to their natural resources and productivity of their human resources. So, that means when we are dealing with all these problems, so the penal data structure will help you lot to investigate the particular process and predict the particular requirement. And similarly, various economic fluctuations and the kind of shocks, the kind of crisis, the kind of upswings, downswings. So, with the help of penal data, so these are all things we can easily detect. For instance, while collecting the data with over the time, so there may be actually some years may be upswing, some years may be downswing. So, the if you don't study the individual impact, then you are not in a position to check which year is very effective and which year is not so effective. So, likewise penal data structure is very useful for problems to investigate the kind of business performance in a more attractive way. So, this is how we are very keen to know this particular technique, and we like to use this particular technique in some kind of business environment. So, in the simple structures, so the usual framework of modeling is with respect to cross sectional, then with respect to time, and then with respect to penal. So, that means technically, so here we have actually two variables y and x, and that will be connected with I and t. So, that means technically I can vary and then t can vary, and similarly y and x can also vary. So, that means at a particular point of times, keeping I equal to 1, then t can vary up to certain point of time. Then similarly, when I equal to 2, then again the data point can vary some extent. When I equal to 3, the data point can vary again like this. So, it will be actually it is a kind of chain, and what will it do? Keeping t constant, then I allow I vary and then do the modeling, and if that is the case, then the particular model is called as cross sectional modeling. In this case, at a particular point of time t will be constant, then allow I vary with respect to y and x. Then when we model this is called as cross sectional modeling. Again allow I to be constant and t should vary. That means, for a particular company, so some observations are there, time series observations are there, that is with respect to y and x, and when we do the modeling, then this is called as model with the time series. So, now what we are doing here, so we are just clubbing time with the cross and doing the same modeling with respect to y and x. So, then it is actually with respect to penal data modeling. So, initially we we pull the kind of structure, then this is called as pull data, and then when we study the impact, the time series impact and cross sectional impact within the particular structure, then it becomes a kind of concept called as penal data modeling. So, now in order to know much better about this particular process, so let us see how we can actually deal with such kind of problems, right. So, these are all things which we have already highlighted. Okay. Okay. So, now when we are dealing with actually time and cross, so the first model we can actually in the deal with this particular series is called as pool data, and then we will go for the penal data. So, now the same problems we can actually simply go through cross sectional and then time series, and finally, we can go with the pool or penal. So, these two are already discussed, and so what we like to do here. So, we are just pulling and do the modeling, and again try to study the impact of individual impact of cross sectional unit and individual impact of time series unit, then it becomes penal data structure. So, obviously, so we like to know now what is the pool data structure and penal data structure, and in what context we will use the pool data analysis and what context we will use the penal data analysis. So, the within the penal data structure, we have a couple of techniques, and again we have to find out the best technique through which the problem can be addressed more effectively. Like we have discussed earlier, diagnostic kind of checks. So, in the penal data structures, we have lots of diagnostics kind of structure through which we have a very variety of models through which we can investigate the problem more effectively and come out with a particular model which can be very useful for the kind of prediction and the kind of inference. And in the case of OLS pool data, the technique is to be used when the data is just combining the cross sectional data and the time series data, and then do the analysis like simple regression structure. So, without any giving the kind of importance to cross sectional hint and the time series hint. So, this is what actually pool data structures. Then when we will go for the penal data structures. So, in the first hand, the penal data can be of two types. One is called as a fixed effect models, and the other one is called as random effect model. In the fixed effect models, so the impact will go to the intercept, and in the case of random effect, the impact will go to the error terms. So, now what what we like to know, that we first prepare the structure, and then we like to highlight how the impact will come to the intercept and how the impact will go to the random term. As a result, we can understand what is the fixed effect model and what is the random effect model. So, now in order to understand this, so let us start with a simple penal data structure here. So, y I t equal to alpha plus beta x I t. So, this is the model, and assuming that like covariance of two error terms should be equal to 0. So, that is how what we have already discussed about the autocorrelation issue, and then covariance of two error terms while I equal to j, that is called as variance, that is called a variance which require, which is the requirement of homoscedasticity, and then again so the sum of the error terms should be equal to 0. So, that means these are the things again we have to validate here in the case of panel data structure. So, that means these are the common things, whether it is a time series or whether it is a cross sectional or whether it is a pool or panel. So, these things are every time need to be checked and clarified accordingly. So, otherwise the model prediction will be getting affected and the management decision will be also accordingly getting affected. In this context, so we have I is the cross sectional indications, and then T is the time series indications. So, usually the panel data structure can be two types, it may be a balanced panel data, it can be unbalanced panel data. In the balanced panel data, if I equal to 5 and every I having actually 10 time series data points, and in the case of balanced panel data, so not necessarily all units having actually balanced time series format, or with every time frame every cross sectional unit should not be also balanced. So, this is how the difference between the balanced panel data and unbalanced panel data. But by the way, this structure will be as usual actually whether it is a balanced panel data or unbalanced panel data, we like to understand and then we will work accordingly. So, in the same in the similar way, so the extension of this model is like this. So, now this is the first hand model, then what will we do? We keep I constant and allow t will vary. So, here y I t and alpha plus beta x I t. So, when I is constant, t can vary from 1 to t, and again so when t is constant, I can vary from 1 to n. So, which in the couple of slides we can highlight this issue. In this case, we y I and beta x I, and here instead of t, so we are putting t equal to 1. So, as a result the first equation will be y I 1 equal to alpha beta x I 1 and then error term. Similarly, when we are putting t equal to 2, then the model will be y I 2 equal to alpha plus beta x I t, then error second error term. Similarly, when it will continue up to tth time period, and again if you proceed for further where I equal to 1, then this becomes the model, and I equal to 2, then this becomes the model. So, that means compared to previous one where I is the constant, we are allowing t vary. In this case, we are actually putting t constant and allowing I equal to vary. So, when I equal to 1, then this will be the model, when I equal to 2, this will be the model, again it will continue when I equal to n, and this is the model. So, that means keep I constant, allow t vary, or keep keep t constant and allow I will vary. So, likewise, so there will be a n number of equation which need to be actually integrated while doing the kind of penalty analysis. So, so every times, so the individual impact will be either going to intercept or it will go to the residuals. So, if it will go to the intercept, then the particular structure will be represented as a kind of fixed effect model, otherwise it will be declared as random effect model. We will go in details about this. So, let us start with fixed effect model. In the fixed effect model, and you see here the full model y I t equal to alpha, and that means technically since it is actually cross sectional units and a time series unit structure is there. So, we can write the model like this. So, y I t equal to alpha plus summations delta I d I plus summations mu j t t j and plus summations beta xit plus uit. So, that means this is the part called as cross sectional dummy, and this is the part called as time series dummy. So, now accordingly we have actually classified here. So, now this is actually dependent variable and this is the original intercept, and then these are the y2 w2 y3 w3, these are all called as cross sectional dummy, and then these are delta 2 z2 delta 3 z3, these are all called as time series dummy. So, now with the help of this data we can create actually dummy structure first, then we like to check actually what is the individual impact individual farm impact and individual time impact. In fact, the way we have already solved a problem in the case of dummy independent molding while studying the quarterly effect between sales and the expenditure. So, here also in the similar fashions you have to highlight and you can actually address this particular problem. And then similarly, if you move further, then the representation will be every time. So, when a particular company will be targeted, that will be represented by 1, otherwise it will be 0. For instance, so when we are saying that W2 equal to 1, then rest of the units will be by default 0. So, the impact will be alpha plus delta, and then rest of the impact will be added subsequently. So, similarly, in the case of time, so when a particular period will be targeted, then dummy will be represented as a 1, then in other case it will be represented as a 0. So, likewise we have actually a big multiple or multivariate regression model through which we can study the individual farm impact and individual time impact while investigating the impact of independent variable on dependent variables. So, likewise so the process will be extended, and by the way, since it is actually I will start from 1 to n, t will start from 1 to t, then the total sample size will be finally n t, and then the degree of freedom will be n t minus n minus t, and this will be with the help of cross sectional integration and the kind of time series integrations. So, then as usual we will set the model and go for the kind of estimations. So, more elaborative where here we allow I t simultaneously if they will go or allowed to vary, then when I equal to 1 t equal to 1, then the model will be represented by y11. This is what actually when I equal to 1 t equal to 1, then this is the model. When I equal to 1 t equal to 2, then y12 equal to this much of. So, this is actually, so we start with dummy 2. So that when other dummies are 0, so this will take care of the first farm impact. So, this will be the second farm impact. Similarly, this will be go for third farm impact. So, here since t is varying, so now it is the first time period impact, and this is actually second time period impact, and this is third time period impact, and that too for a cross sectional unit 1. So, likewise you can go for allow time constant, then I can vary, then individual farm impact second farm impact like this. So, it is a kind of continuous process through which you can understand the particular problem, and then we can address the kind of issues in a more attractive way. So, here when I putting I equal to 2, then again the model will be extend simultaneously. So, so I equal to 2, then alpha, then the second variable impact, then accordingly it will extend subsequently. So, these are the kind of structures. So, this is I equal to 2 and t equal to 1. So, this is the first model. When I equal to 2 t equal to 2, then this will be the subsequent model. So, likewise, so this model can be extended. These are all mathematics behind this particular penal data structure, but ultimately if you understand the particular data and represent in the form of a kind of dummy structure, then estimations and this design of the model will not be actually problematic. So, like dummy structure, it will be just integrated and then estimated as per the particular requirement and the particular objectives. So, now here what will you do? So, we like to proceed again, and then again, so when will we go for kind of time impact. So, the particular structure will extend accordingly. So, now what will you do? We like to check whether we like to follow the kind of pool data models, or we like to follow the fixed effect models. So, the particular extension is nothing but actually fixed effect models. So, but when we will go for pool data model, we can just pull the data and then investigate the issue between y and x, like this here. So, here just y and x, then the rest of the components individual impact will be removed, but in the case of fixed effect model, so these are will be incorporated. So, now the question is whether pooled model will be effective or random effect model will be effective. So, in that context, so we can go for test, and then the F test will give you the indication whether the particular model is effective for this particular problems, and then accordingly we have to choose whether we can go ahead with the pool data modeling, or we will go with the panel data modeling, that to fixed effect model. And again in the case of random effect model, so the typical structure will be like this, and here we are not allowing the impact to go to the intercept, we will allow the impact will go to the error terms. As a result, so the total error term will be composed of UI, VT, and then finally WIT. So, UI deals with cross sectional, the error term dealing with the cross sectional effect, then VT represents the kind of an error term dealing with the time series effect, then WIT it is a kind of while pulling both time and cross. Accordingly, so it will be exactly followed by homoscedasticity, and accordingly this should be unit variance with respect to u, v and w, and the cross correlation coefficients means autocorrelation coefficient should be equal to 0. So, this is as usual again a requirement whether it is actually fixed effect model or random effect models. So, now we get to know now three types of models: pool models, fixed effect models, and random effect model. And then in the first hand we like to choose which model is the best. First choice is whether actually pool or panel. Again in the panels whether to choose actually fixed effect model or random effect model. So, there is a procedure through which actually we have to check and then finally freeze the particular model as per the requirement of prediction, and this model will be free from all kinds of error, and this will give you as per the structure of the panel data modeling. So, now going ahead about this particular issue. So, the random effect model case, so the total variance error variance will be a sigma square u, sigma square v, and sigma square w. So, that means it is the error variance with respect to cross sectional impact, and then error variance with respect to time impact, and then error variance with respect to pool impact. So, as a result, so it will have a three different error variance. Then now the choice between actually random effect models or fixed effect model. So, we have some kind of test. So, here we are assuming that in the OLS mechanism sigma square u and sigma square v, and then we like to actually estimate the process as a kind of structure called as generalized least square methods, because in the case of panel data modeling, particularly random effect model. So, the usual OLS structure will not work, and then we will go for generalized least square mechanism. So, what will you do? First we take the problem and investigate with the pool data, and again we will go ahead with the fixed effect model, and then come with random effect model. So, now between random effect model and fixed effect models, there are lots of criteria which one is the best, but in the theoretical grounds it depends upon the choice depending upon the size of t and n. So, t represents the a time length and n represents the cross sectional length. So, when time length exceeds cross sectional length, then a fixed effect model will be more effective to study the individual farm impact, and when n greater than to t, then in that context theoretically random effect model will be more effective to justify the kind of model, and then go ahead with the kind of prediction structure. But by the way, so we have actually statistical structure through which we can check the random effect model and fixed effect model. We have lots of fitness indicators and the kind of test like Houseman test, through which we can actually in a position to justify which particular model will be finally taken into consideration for this prediction. So, that means it depends upon a particular problem, the kind of size of data, the kind of variables involved in the process, and then a model with the help of model results and fitness indicators indications, we have to finally freeze which one is the good fit for the kind of requirement. So, now in order to analyze the particular structure, so we start with a simple example, and here the example will be like this. We have here 4 companies, and the time period which we have taken is 10 different yearly structure, and the problem which we like to address here is cost versus output. So, that means we like to know what is the relationship between cost and output with the help of 4 different companies and 10 different time periods. So, technically it has a 4 companies information with 10 different time periods. Of course, 10 different time period is a small one, but we can have actually individual company analysis. So, that means for individual company analysis, so using 10 different time periods, you can just connect with the C and Q. Of course, it is a small data set, even if 4 companies having instead of 10, if you have 100 time data points, then obviously by default you have actually 4 different models for 4 different companies, and that too using the time series data, and then to investigate the link between output to cost. But by the way, now in the case of panel data modeling, so we can just pull all the data, the same impact we can actually observe, and that too the relationship between output and cost. Now, since it is a industry problem, because we are actually clubbing all the company, and then within the pool of all companies, and we like to investigate the relationship between output and cost, and within the particular pooling, we like to check which particular company is more effective. So, that means the idea is to justify here which particular farm is more efficient so far as cost is concerned. So, technically the objective will be, so if we fix actually output at a particular point of time or given a particular level of output, then we like to check which particular company will be more efficient, and that too with respect to less cost. So, panel data structure is and the panel data structure or panel data modeling will be very effective tool here, and to address this particular problems, right. So, how we have to actually deal with this problem, and that we will discuss here after the break here. Thank you very much. Have a nice time.